Okay, so we have statistics 3, population proportion, type 3, finding n, the sample size. So here we have a random sample of 250 cars were surveyed passing a certain junction, and 36 were found to have K registrations. So we have 36 over 250, and the first thing we want to do is determine our 95% confidence interval for the proportion of cars in that area. Okay, so to set up our 95% population proportion, what we have is our sample population proportion plus or minus our 1.96, our critical value for our 95% confidence interval, times the standard error for proportion. And the standard error for proportion is given on page 34 in your maths tables. And when we don't know the true population proportion, we take our sample population proportion. That's it for n. Okay, so let's separate this out. So we have to work out our sample population proportion first, which is x over n. And in this case, we can see that n, our sample size, is 250 and x is 36. So our sample population proportion is 36 over 250. And that simplifies down nicely to 0.144. So if I then sub that into my expanded formula, so therefore I have 1.96 less than our true population proportion. And our sample. Then if I sub my values in, I can work out my 95% confidence interval. So we're going to have 0.144 minus 1.96 times 0.144 times 1 minus 0.144 all over the sample size, which is 250. And that's less than the true population proportion. And that's 0.144 plus this time 1.96 times 0.144 times 1 minus 0.144 all over our sample size, which is 250. Okay, so if we put all of that into our calculator then, what we end up with is 0.1005, less than our true population, which is less than 0.1875. Okay, so you can write that as a percentage, or we can leave it as a decimal. Either is correct. Now, if we look at part 2, you can see it's known nationally that 14% of the cars have a K registration. So they're referring to percentages in the second part of the question. So you could, of course, change this then, which looks a bit more kind of relatable to part 2 of the question. But as I said, either of these are your answer. They're correct. Both of those represent the 95% confidence interval for your population proportion. Okay, so part 2 then says it's known nationally that 14% of the cars have a K registration, and we're asked what sample size would have to be taken, so again that we are 95% certain, so that's really important for our critical values of 1.96, that an estimate of the proportion of K registrations is within plus or minus 2% of the population. So our plus or minus 2% of the population is, of course, our margin of error, and then our value that we're checking for is our sample population proportion, which is what we worked out there, our 0.144. And then we're going to sub that into our values to work out what is n going to be. So if we're given our margin of error, we have to remember our margin error is plus or minus our critical value times our sample standard error of our proportion. And if we don't know what our true population proportion is, we would change that to p hat. And when it's a 95% confidence interval, Z, our critical value is 1.96. So in this question here, we're told that it's known nationally that 14% of the cars have a K registration. So we're told the true population proportion. And we will then look at the fact that we're told we are 95% certain. So therefore, our margin of error must be plus or minus 0.02, in other words, 2%. And then that would be equal to plus or minus our 1.96, our critical value, because we're told it's 95% confidence. And we were given the fact that P was equal to 14%, so in other words 0.14. So we're going to have 0.14 times 1 minus 0.14 over n, which is what we're looking for. So obviously this plus or minus is going to go here. So we'll have 0.02 is equal to plus or minus 1.96 times the square root of 0.1204 over n. And let me just get rid of that plus or minus there. So then we want to do is obviously get n on its own. So I'm going to divide both sides across by 1.96. And then we're going to obviously have to square both sides to get rid of the square root sign. And then if I cross multiply there, then we end up with n being, so that gives us 1156.3216. And obviously n has to be a natural number. So if we're looking at that, we have to be within plus or minus 0.02. So if we round up or we round down, does it give us within the 2% or outside of the 2%? So subbing in 1156 would give us just outside the 2% margin of error, where if we're putting in our nearest whole number, we have 1157, which will give us within our 2% value for our sample size. Okay. So if we recap there on part 1, a lot of the times in the Leaving Cert, they'll actually ask you to interpretate your 95% confidence interval. And if you're interpreting your 95% confidence interval, what we would say is, i.e., we can say with 95% confidence that between 10.05% and 18.75% of cars have a K-reg. So if we were to say, are we consistent with the statement that it is 14% in the second part, well then that would be true, wouldn't it? Because 14% is lying within that interval.